Are you smarter than a 16-year-old? Well, we're about to find out today because we'll be taking a look at one of the most, at least in my opinion, difficult questions that I've seen on a GCSE paper. This came up on the 2024 Edexcel paper 3. It was the last question on the paper, and just as a disclaimer, I did spend an unreasonable amount of time trying to figure out my own solution for this, and that's the solution I'll be presenting. However, there are other ways that you can solve this. So if you want to take a crack at this question yourself, now would be a good time to pause the video, try it yourself, and come back. Okay, so let's get into the solution. First of all, let's read the question. The diagram shows a circle, radius r centimeters, and two regular hexagons. Each side of the larger hexagon, A, B, C, D, E, F, is a tangent to the circle, which you can see over here, it's a tangent. And each side of the smaller hexagon, P, Q, R, S, T, U, is a chord of the circle. By considering the perimeters, we need to show that pi is greater than 3 and less than 2 root 3. First of all, I would start with an origin point O, which I'm just going to mark on myself so that we can work from this. So we have this origin O that we'll be working from. We want to create two triangles. Now that we've got the smaller triangle for the smaller hexagon drawn on, we can start to take a look at the properties of a hexagon that would allow us to break this problem down into simpler pieces. So first of all, we have the fact that this angle over here should be 6. So 360 divided by 6 gives us 60 degrees. So we know that this angle over here is going to be 60 degrees combined. And now we need to take a look at what we can do with this information. We're given that this radius that we have from O to U is going to be r centimeters. And that would be true for this here, r centimeters, r centimeters. Given the fact that the radius is r centimeters and this overall angle is 60 degrees, we can actually break this problem down even further, because this is a chord, and the properties of a chord state that if you have this line going through, meeting the chord here or bisecting the chord, then you'll have a right angle here and a right angle there, and that will give us two right angled triangles, and we love those. So now what you want to do is you want to split this angle up into two smaller angles. So you have, given that this is 30 degrees, but now what we want to do is create an expression for this line, which we're going to call our opposite O. So we have sine theta is going to be equal to our opposite over our hypotenuse. Therefore, sine of 30 is going to be equal to our opposite divided by our radius, r. Now, I know that sine 30 is a half, but since this is a calculated paper, you can verify that yourself, and we can put that in here. So sine of 30, there you go, it's a half. So a half is going to be equal to our opposite divided by our radius. Our opposite is going to be equal to half times by the radius, which essentially means that this over here is going to be half a radius length, and therefore this full line going from U to P, so the length of our chord, is going to be radius is equal to one side of our smaller hexagon. So now that we have one side of our smaller hexagon, which will be this, so this is also r, this is r. You can also deduce this, by the way, by noting that it's an equilateral triangle, and therefore all the sides should be the same length. So if this is r centimeters, that should also be r centimeters in length. Now we're going to multiply this by 6 to get our perimeter. The smaller hexagon, one side is equal to r, therefore the perimeter is going to be equal to 6r. So we have our expression for the perimeter of the smaller hexagon. Now for the larger hexagon, what I'm going to do is I'm going to draw another triangle, but over here. So what I've done over here is that I've essentially created a new triangle. The radius of this circle is going to be perpendicular to the tangent of the circle, which will be this side of the hexagon, we know already that this angle is also going to be 30 degrees, as this is also just a regular hexagon, so it's the same process that we used here. First of all, let me redraw the triangle that we have. We can create an equation again using trig to get this side b. Tan theta will be equal to our opposite over our adjacent. Because if we see and label these sides correctly, well, this is clearly the opposite, and this will be the adjacent, as the hypotenuse will be the longest side, or in this case, C. Tan of 30 is going to be equal to our B, our desired side, divided by R. Now, all we need to do is calculate what tan 30 is, so we can plug that into our calculator. Do tan of 30. Make sure that your calculator is in degrees, of course. And you get root 3 over 3. We can say root 3 over 3, R is equal to B. But remember, this isn't the value that we're looking for, because if we go back over here to our hexagon, B is just half of one side. So we need to times this by 2 in order to get the full side length. So we can say that the side of the larger hexagon is going to be 2 root 3 over 3 R. So now all we need to do is we need to multiply this through by 6 in order to get the perimeter of the larger hexagon. So let's come back here. So larger hexagon. And we can say one side is equal to 2 root 3 over 3R. Therefore, the perimeter is going to be equal to 12 root 3 over 3R. Or in other words, the perimeter is going to be equal to, now you can just simplify, divide 12 through by 3, and that gives you 4 root 3R. Before we have all the expressions that we need, the last missing expression that we need is going to be for the circle itself. So for a circle, we know that the perimeter, or in other words, the circumference, is 2 pi r. So let's write that down. The circumference of a circle is equal to 2 pi r. And that would be the perimeter of the circle, right? So now we create our inequality because we know, looking from this shape, that the smallest perimeter will be the shape on the inside, which is this hexagon. We can clearly see that this will have the smallest perimeter. Then it will be the circle, and then the greater perimeter still will be the larger hexagon on the outside. We have the perimeter of the smaller hexagon, which is going to be 6r. It's going to be less than 2 pi r, which is our circumference of our circle, which is going to be less than still the perimeter of our larger hexagon, which we figured was 4 root 3r. Now it's simply a case of simplifying what we have over here down to the desired form. So we can see over here that we have 6r, 2 pi r, and 4 root 3r. Well, what do all of these have in common? They have an r in common. So the first thing we can do is we can eliminate this r. So let's cancel that. The r gets eliminated, and we're left with 6, 2 pi, and 4 root 3. Now the final step of this question is that we can divide through by 2 for everything, and that will give us 3 is less than pi, and pi is less than 2 root 3, which if we look at the question is exactly what they were asking for. So then, are you smarter than a 16-year-old? Well, let me know in the comments, leave a like, subscribe, and I'll see you in the next video.